Okay, so let's have a look at some of these exponent properties that we studied last week and just quickly review what we're talking about. 5 squared is 5 times 5, and 5 to the third is 5 times 5 times 5. If I add these up, I see I've got 1, 2, 3, 4, 5 fives, which means this expression is equivalent to 5 to the 5th power. What I also noticed is that since I knew I had 2 5s and then 3 more, I could actually just realize that I could use what's called this addition property of exponents, which means that if I add these exponents when I'm multiplying two numbers with the same base, that saves me the time of having to write it out. However, if you ever get confused, you don't have to memorize that rule. You could always just do what we did here, write it out and figure out for yourself what the answer is. Now this case is a little different because of these parentheses here. These parentheses indicate that whatever it is that's back behind inside here is getting multiplied by itself 4 times. So that means that this is 3 to the third times itself 4 times. And if I wrote that all out as we did before, I'd get one group of 3, 2, 3 groups of 3, and finally, so that if you look carefully, here's 3 to the third once, 3 to the third twice, 3 to the third time, and 4. Altogether, what we should see is that if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that my answer is 3 to the 12th. But we can also see that I basically have 4 groups. Each group has 3 3s in it, and 4 groups of 3 implies 4 times 3. So what we could have just done is said, well, this is going to be equivalent to 3 to the 3 times 4 power. Sloppy there. 3 to the 12th. All right, this one's a little bit different because now we've got a fraction. But if we think back to what exponents mean and what basic fraction multiplication looks like, we know that this is x times x times x, a total of 6 times. And then a denominator, we have x times x times x. Now we also hopefully remember from earlier math work that when I multiply fractions, I can just multiply across the top and the bottom. So really that this is equal to x over x times x over x times x over x, and then I would have 3 x's left. And if I wanted to keep it looking like a fraction, I would just put each of those over 1. Hopefully we all remember as well that any number, with the exception of 0, any number divided by itself always equals 1. So this equals 1 times 1 times 1. And then what's left here is these x times x times x, and that's just equal to x to the third. So our final answer here, x to the third. But again, there's a shortcut, which is to notice that these 3 down here are going to be taken out, canceled out, by these 3 up at the top. And that implies that we're going to be subtracting. We're going to take these away, and we're going to have these 6, and we're going to take away these 3, canceled out by these 3. So another way to approach this problem is to see it as x to the 6 minus 3 power. So x to the third. My pen wasn't working very well there. So those are the basic properties of products and power to a power as well as division. In the next video, we'll look at 0 exponents and negative exponents.